So we just like to begin with an acknowledgement of country, and that in the spirit of reconciliation, Zengo Australia acknowledges the traditional custodians of the country throughout Australia and their connections to land, sea and community. We pay our respects to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. And now I'd just like to introduce our panellists. Greg Neal has taught for over 40 years and was head of mathematics at Ballarat High School. He has been a VCA examination assessor for maths methods for about 20 years and has a lot of expertise in CAS technology. He's written a range of texts, including our new series, Nelson VICmaths. And our other expert today is Robert Yen. Robert is a very experienced teacher as well, and a very, very experienced publisher and author, and the author of the best-selling New Century Maths. Over to you, Greg and Robert.
All right, thanks, Jess. Robert. So the presentation tonight, we've broken up into three main sections. We'll look at the study design, things that have changed with the new study design next year. Robert will take you through a sample chapter from maths methods, and we'll look at the features of our textbook, and then we'll be back to me. We'll look at a VCE question analysis, features of the question and how you read the question, and look at the solutions and how CAS is used in those sorts of solutions as well, and see how the examiner's report helps with all of those details. So firstly, with the structure of the study design, there are now 4 different subjects in mathematics, and each of those are units 1 to 4, which wasn't the case with foundation maths before. Every subject now has compulsory units, so there are no options. The further maths has now been renamed as general maths units 3 and 4, and there have been some changes to assessment weighting. So we'll see for our assessments. So the internal coursework assessment is now 20% for unit 3 and 20% for unit 4. So that's up from 17. Exam 1 is now 20% and exam 2 is now 40%. So the difference that makes is that previously the school assessed coursework or the examinations were worth twice as much as the school assessed coursework. So it was like 66 compared to 34, and now it's worth, the examinations are now worth 50% more, so it's now 60 versus 40. The areas of study are functions, relations and graphs, and algebra, number and structure, and calculus, and data analysis, probability and statistics. And each unit of mathematics covers each of those 4 areas. So basically we're looking at the algebra component for the second area of study and probability and statistics for the last area of study. Generally speaking, the changes to maths methods have been fairly minor, but there have been changes where the study, where content is being rearranged, like in unit 1 and 2, and the study's been enhanced by some of the content changes. So this shows you for unit 1, 2, the chapters for the Nelson text for unit 1, 2, and for unit 3, 4. So we'll look at some of those in a little bit of detail as we go through. So this is like for unit 1. It shows you that we've got in the functions, relations and graphs, we've got those chapters, functions and graphs, polynomials and transformations. There's now like some calculus and rates of change calculus in unit 1. prior to that, you probably would have come across that in Unit 2. There's now some introductory probability and counting methods, so that's in Unit 1 as well. So what's been removed from the study design? So the non-function relationships have been removed. So things like equations of circles, that won't be covered in Unit 1 or 2. And the vertical line test for functions, so that's been removed as well. By saying it's been removed, it doesn't mean that you can't teach it to help enhance students' understanding of what a function is. But it probably means more that it can't be used as an explanation for why something is a function. So the matrices, so that's been removed as well. Matrices is now optional for transformations, but it's still included in specialist maths. And the matrix representation for transformations, you can use it, but it's not required. So we would expect that that it can't be examined then. So we'll look at some of the rearrangement that's occurred. So there's been content that's been rearranged in Unit 1 and 2 with probability. And in a lot of ways, it will help students' understanding of probability when it's done. So there's now in Unit 1, probability and counting methods. So the language of probability is covered. Another thing which I think is a benefit is the fact that random variables as a concept has been introduced. So you might, for example, cover rolling a die and then looking at the sum of the numbers that occur on the roll of the die. But you can define that now as a random variable. A discrete random variable X might represent the sum of those two numbers. And then you could ask students what would the probability be that X was equal to 8. So even though you're covering work that's students would have done anyway normally, we're actually introducing that concept of what a discrete random variable is in the context of those particular problems. So probability simulation is included in that Unit 1 work as well. And as well as that, like all the addition, like the counting methods work on permutations and combinations and how that applies to probability. Then the formal probability theory involving Venn diagrams and tree diagrams and conditional probability, that's all done in Unit 2. Now I've included here one of the worked examples on probability simulation. So in this particular example, we have a baseball player who knows that he's capable of hitting a home run twice in every 10 bats. And in every game, he has 2 bats. So what we could do here is we could use a random number generator to simulate that likelihood. And then all we need to do is to say, well, if that's 2 in every 10, we need to allocate 2 of those random numbers between 0 and 9 to being a home run. And then the other numbers where he doesn't hit a home run. And then we can generate random pairs of numbers. In this particular case, they've generated 50 games and then use those 50 games to determine those probabilities. So it means that when you're doing that, you can actually look at simple probability problems, but you can also look at problems that are a lot more complex than you'd be able to do with like a purely theoretical approach. So the other thing which there's been quite a bit of change to in Unit 1 is the calculus work. That's mainly to do with like numerical approximations. So we'll look and see what sort of things have changed. Now, I'll mention later on about the fact that in Unit 1 and 2, that mathematical investigations have been introduced. So that in a lot of ways, that will help students prepare for what they'll have to do in Year 12. But it also means that there's particular things that really lend themselves towards mathematical investigation in year 11 where you have a lot more freedom. One of those would be like the probability simulation. You could develop really good investigations for year 11 for students when they do those. So rather than just teaching simulation using an exercise, you can use that context to actually get students to investigate something in detail. And the other thing, another good approach would be to use this new content on like sort of first principles derivatives. So the change that's brought about is when they look at the derivative, they look at the approximation when you approach from the left-hand side of a point and then you approach from the right-hand side of a point. So I was looking at some of this today, and I thought, well, if we wanted to look at, let's say we were looking at a function like y equals x cubed, and we wanted to work out an approximation for the derivative at x equals 1, we could look at different values of h, say 0.1 to the left of 1 and 0.1 to the right of 1, and look at the gradient between those 2 points. We could change that value of h and see what happens to those particular approximations. The other thing we could do is we could change the function, or we could see, well, if we weren't dealing with y equals x squared or dealing with y equals x cubed, how would that change? Is the limit to the left for the same h value always the same as the limit to the right? Does it make any difference whether the function's concave up or concave down? So there's lots of different things that students could look at in an investigation of this type. This would really sort of enhance their understanding of derivatives and of limits and exactly what the gradient function or the rate of change at a particular point is. So the other thing which has been introduced is the central difference approximation, where you approximate the gradient at a particular point A by looking at two values, the same distance either side of A, one at A take H and A plus H. As an investigation, it could also be something that could be included as part of that project or investigation. The rates of change really is, rather than being a formal algebraic approach to calculus, is really a numerical approach to how those particular rates of change work. And I've talked about this in quite a bit of detail, how the Unit 1, 2 now have a mathematical investigation. All right, so let's look at Unit 3, 4. So the f of g of x has now been introduced as a new notation, that FOG, or like we used to call them fogs and goffs. So that's just a notation change rather than a new content, really. The functional algebra has now been removed from study design. So we would have come across questions in the past, like if f of AB equals f of A times f of B, which of the following could be y equals f of x? And then you'd be given a whole lot of optional choice responses to look and see which function actually works with that particular type of functional algebra. So that's now out. And the matrices we said for transformations, that's been removed as well. And so in Unit 4, this is, so this is really a word change. So we would have done absolute maximums and absolute minimums. They were examined, and it's now called global maximum or global minimum. The trapezium rule for approximating areas is now being reintroduced. So this is something that was in the study design before this one, and then it was removed, and now it's back in again. Newton's method for approximating roots of polynomial functions was included in the current study design in Unit 1, 2, and it's now been extended for non-polynomial functions like exponentials or log functions. So that's now in year 12 also. And so the median for continuous probability distributions, that's also been removed from the study design. And so these are just some shots which just show a trapezium rule and a global maximum and global minimum as compared to local maximums and local minimums when they're the same and when they're different. So when we look at the assessment, the type of assessment is now exactly the same. So the application task is still there. That's worth 20% of the study score. And for unit 2, there's still 2 modeling problem solving tasks. One of those has to be on data analysis, probability and statistics. So that's the only change there is the percentages rather than the task. And so now I'll hand over to Robert, who will take us through the features of the sample chapter.
Yeah, thanks, Greg. Before I start, what are your impressions of the revised study design? Do you think it's an improvement?
Yeah, well, certainly with the things that have been put in, even though some of those changes are minor, there's a lot of scope for actually improving students' understanding of the work. I know definitely with the probability work, the fact that they try it, the thing that will happen was that students' understanding of random variables will be very different, whereas before they really only mentioned when you got to year 12 and it was like you were learning something completely new. So the fact that some of that language is introduced and students are given the opportunity to develop an understanding of concepts, I think that's an improvement also.
Okay. All right. Hi, everyone. I'm going to show you a chapter from the Year 12 book, and it's chapter 5 called Functions and Transformations. So when you open up to the front of that chapter, you do get a table of contents. So it's showing you there that you get like 6 sections in this chapter, from transformations of graphs to piecewise functions. And then on the right-hand side, you've got the actual study design coverage. So we've taken the extract from the study design that's covered in this chapter. And then underneath that, we've got all the resources that are available on our online learning platform called Nelson VICmaths. So we've got video playlists. So we've got videos associated with each section of the chapter. And we've also got worksheets there. Greg, next page, please. And then we go straight into the chapter. So it's 5.1 transformations of graphs. And you can see that, what have we got there? We've got some explanation. We've got words in blue. Any words that are blue are in the glossary. They're glossary terms. And we've also got using CAS, which I'll show you a close-up of in a minute. But Greg, if you can click the next one, there's some icons there on the side that show you, that indicate the items, the worksheets or the videos that are available on our online learning platform. And then, and as I said before, using CAS, I'll just show you it in close-up now, Greg. So it provides instructions in both TI Inspire and ClassPad side by side. So we've tried to summarize the steps really concisely so that you can see those steps. So we've got an application of using CAS, and here it says using CAS to find dilation from the x-axis, and we've got the instructions listed side by side there. Okay, next page. All right, here's an example of a worked example. So again, with the worked example, we have the title of the worked example next to it. So again, this is dilation from the y-axis, and we've got the steps involved in solving in the solution listed on the left, and then we've got the working written there on the right. And then we've got some more theory, like on translations. One thing we've tried to do is not have a whole page of text. We've tried to chunk it into smaller sections, because with 21st century learners, they need to digest, well, actually 21st century teachers as well. We need to digest information in bite-sized chunks. So you'll notice that we do not have really, really long explanations. We don't have long-winded, wordy explanations. We try to break it down, and we include these things called exam hacks, which Greg, can you close up on the exam hack? Yep, so here's an exam hack on, with transformations, it's very important that you use correct terminology, and Greg's an assessor, and he'll tell you that a dilation or translation is from the axis or parallel or in the direction of an axis, but a reflection is in an axis, and you should avoid using terms like horizontal and vertical. So exam hacks contain valuable hints from the assessors, from the exam reports, and they also highlight common student errors as well. And a lot of our author team, there's 5 authors working on this book. A lot of them are quite experienced assessors. So you'll find throughout most pages will have an exam hack giving you some tips on how to do well in the exam. Okay, next page. Okay, so next section is called combined transformations, and any kind of rule or formula that's important to know, any facts or formulas, we'll put in one of these shaded boxes. So here we're talking about combined transformations and the importance of using the Dr. T rule or the DRT rule. And there's another example there. Okay, next page. Here is 5.5 composite functions featuring the new FOG notation. Or GOF, pronounced GOF. Okay, next page. And you'll see that we do something different with the exercises that that you might not have seen before. We've actually broken down our exercises into 3 sections. So the first section is called recap, and recap is basically 2 questions from the previous exercise. So it's a nice lesson starter for teachers. It's also nice for students to remember, recap what they learned in the previous lesson. Greg, can you click the next 2, please? Because the labels come up, and then next one. And then mastery, I'll go back now, please. Mastery is your typical textbook question. So it's skill practice of what you need to know. And then the third section, yep, that's mastery there. And you'll also notice that it's linked to a worked example, or also linked to using CAS. And then the third section is called exam practice, and that's exactly what it is. It's unusual, but this screen actually has all exam questions there are past VCE questions. So they're actual, so they're students that are practicing actual past VCE questions. And as you know, in methods, we have exam 1 questions, which are tech-free. So they're listed first. And then we have exam 2 part A, which are multiple choice questions. They're listed second. And then finally, we have exam 2 section B, which are your written response or short answer questions. So, and you'll notice that we've got success percentages there. These are based on the exam reports and actual VCAR data on how students went that year. And basically what a success percentage is it's the average percentage mark for that question. So we've also color coded them. So anything over 80 is a green straightforward question. Most questions are between 60 and 79%. They're standard orange questions, and anything below 60 is a complex blue question. And we've tried to, within each exam question, we've tried to rank them in order from easy to hard. So you'll find the green or orange questions first, and you'll find the blue questions last. Okay, can you just Greg click the next one? I just wanted to show you up the question close up. You'll notice, so there's codes in the front of each question. So if you have a look at question 16, it says 2020 2AQ1, which means it's from the 2020 VCE exam, exam two part A question 1. That's right. And it's 84% of students got that question right because it was a multiple choice question. So 84% of students chose that answer, the correct answer. Okay, next slide. Oh, and when we get to the end of a chapter, we have something called VCE question analysis, where we select a question that best exemplifies this chapter, that covers a lot of the skills learned in this chapter. And we just do a deep unpacking of that question for students from the expert teacher. So you'll have things like, well, you'll see there's highlighting of keywords. So there's showing students what are the important things to do to know when you're reading the question. And in fact, the first section is called reading the question, Greg. And then, so there's a section, some tips on how to read a question or this question, some tips on thinking about the question, and then the work solution shown fully, and there's a tick shown for where you earn each mark. And then finally, the last part of that is the student performance, Greg, and that is some feedback from the exam report on how students went on each question, and some of the comments from the assessors. Okay, next slide. When you get to the end of the chapter, then you expect to have a chapter summary, which is what we've got there. And then instead of a chapter revision quiz, we have something called cumulative exams. So we've got two cumulative exams at the end of every chapter. So exam 1 is like an exam 1 from the VCE exam. They're basically mini exams. They're a quarter of the size of a normal exam, and they're based on the format of the VCE exams. So for example, this is cumulative exam 1, so it's tech free. Normally it would go for 1 hour, but this is a mini exam, so it only goes for 15 minutes, and the total number of marks is 10. With the thing with a cumulative exam is that 50% of the questions are on the current chapter, but the other 50% are on work skills from previous chapters. So with our style of textbook, when you get to the end of a chapter, you're not only revising the current chapter, but you're also revising previous work. Okay, let's have a look at exam 2. So we've got the section A with the multiple choice questions, and then section B, next page, is the short answer questions. So here we've got 4 questions worth a total of 15 marks. And then what else do you expect at the end of a textbook? I think it's the glossary and index. So we've got a combined glossary and index showing you all those important words in blue bold with their page references. Okay, now it's back to Greg, and he's going to be leading you through the VCE question analysis for this chapter.
All right, thanks very much, Robert. So what I want to do was to look at this question from 2014. It's predominantly on transformations, and just go through how we try and help students sort of read the question, look at what's important in the question, try and analyze exactly how to go about solving the question, and then we'll look at the actual solution. So this question 2014, this was a fairly difficult question. See, when we look at the student responses, exactly what the percentage results were going to be. One thing students often miss when they're doing these sorts of questions is they'll often miss what sort of an answer they're supposed to get, whether the question's asking them to show something. Can they do the whole thing on CAS? Is that fine to do that? Often questions will have sort of multiple parts in them too. And it's common enough to see a question where, like a student response, where 2 answers have been required, but only one's been given. So we just want to make sure that students, when they're looking over that, they actually provide all the information that's necessary. So we mentioned this about reading the question, what are the important things to take out of it, what sort of mathematics is needed when we end up going through and then analysing that. One thing we've said down there, especially with methods questions, is that if they, an exam 2, they give the functions, you're going to be using those functions quite a bit. So students want to make sure that they define the functions on their CAS so that they can use their CAS as much as they can to find answers and to help them justify whether they're getting the right sort of solutions. So let's have a look at this first part. So we've got 2 functions here. We've got this quartic f of x and another quartic g of x. And what the question's asking him to do is just to express that quartic in that form. You can see in our solution down the bottom, like the g of x function's been defined, it's been factorized, but when it's factorized, it's given an x and x minus 2, but it hasn't given an x plus b squared plus c. And to do that, you need to complete the square on the last term. Now what the examiners found, so that was fairly well done, like 58%, but quite a few students didn't do that very last part. They didn't do the very last completing the square. Some tried to do the whole thing by hand, which isn't necessary when they're doing questions like this in exam 2. So in the next part, we had to work out what translations are going to map f of x onto g of x. And if we look very closely at our factorized form, so our x squared, our f of x in the last bracket has got an x squared plus 3, and our g of x in the last bracket has got an x plus 1 squared plus 3. So we can see when we look at that first, or the x in that third bracket has been replaced with an x plus 1. So let's see if we were to replace all the x's in f of x with x plus 1. So x plus 1 take 3, that would make x take 2. So that's in g of x. And if I replace the second bracket and make that an x plus 1, that would be x plus 1 take 1, that's x. So we can see that changing x into x plus 1, that would end up giving us the g of x function. And if we change x to x plus 1, that actually translates the graph 1 unit to the left. Now, because students have already defined f of x and g of x, it's very easy for them to actually graph the 2 functions. If they do that, then it will be obvious which way the graph has moved. A number of students, when they looked at that x changed to x plus 1, thought that that translation was 1 in the positive direction of x, whereas in fact it's going to move it to the left. It's going to move it in the negative x direction. Another thing they could have done is they could have said that x changed it to x prime plus 1, which means that x prime would be equal to x take 1. So, and that would also show them which way the translation would have worked. But CAS is a pretty easy way to do it. Even so, it was only like 37% got that right. So here in the next part C, we're trying to work out for our f of x, find the values of d such that the graph of f of x plus d has got either 1 positive x-intercept or 2. And so we need to think about the fact that an x plus d is going to end up moving at d units to the left. So let's have a look at our graph of y equals f of x. At the moment, it has 2 x-intercepts. If I want this to have 1 x-intercept, then I need to move the graph at least 1 unit to the left. which means that I know looking at that, that D must be at least bigger than or equal to 1, but I can't move it any more than 3 units to the left, because otherwise I'm going to lose that x-intercept of x equals 3 as well, which means that my D value needs to be bigger than or equal to 1, but also needs to be less than 3, which means that D has to be in between 1 and 3, including 1, but not including the 3. Now, unfortunately, like marking that, I remember, even though it was back in 2014, that a number of students didn't get the mark for that. They got the 1 and 3, but they didn't get the inclusive, exclusive terms right. So they actually needed square bracket for 1, comma, and then round bracket next to the 3. Now, if we want to end up having 2 x-intercepts, then that means that I need to move it less than 1 unit to the right, to the left, I mean, which means that D's got to be less than 1. And you can see from our success percentages that we only got 7% for part 1. We've got 19% for part 2. So pretty low. So like I said, even though a lot of students had the idea about the translation, they needed to make sure that they get the brackets correct. All right. So in this particular question, they're saying, find the value of n for which the equation g of x is equal to n has got one solution. I think the best way to think about this is that we're looking at 2 functions. We've got y equals g of x. We can see is this quartic here that's sketched, got x-intercepts of 0 and 2, and another function y equals n, which is a horizontal line. Now, if that horizontal line was, say, above the x-axis, if you follow my cursor there, you can see that would give us 2 solutions. The only way that can only have 1 solution is if we end up moving it down, so it just touches g of x at that stationary point. Now, if we solve the derivative of g of x is equal to 0, that tells us that x is equal to 2/3. But we need to be thinking about the fact that n is actually y equals n. It's when g of x is equal to n. So they're not after the x value, they're after the y value. So we need to do g of 2/3 to work out what n is equal to. Again, we've only got like 17%. We needed to make sure we got an exact value, not an approximation. And students needed to give the y value, not the x. So again, a few students had the right idea there and knew what they were doing, but got x equals 2 to the 1/3, but they didn't get the y value. It was only like a 1-mark answer. So we needed an answer correct there. All right, so the last part we're going to look at is part E. And in this particular paper, this was question 5 in a 2014 exam too. And I think like part E, that's a difficult question to read because you've got at a point U, G of U, the gradient of y equals G of X is M. And at a point V, G of V, the gradient is negative M. The students often, there's a lot of maths there to read and interpret. And students, I remember looking at, there were actually a lot of non-attempts at that particular question. We've got to work out, well, what's the value of U cubed plus V cubed? So here we've said, well, because it's a gradient, students need to think about the fact that we want G dashed of X to be equal to M at X equals U. And this was worth 2 marks. You could quite easily have just written the function notation. If you had to put G dashed of U equals M and G dashed of V equals negative M, that would have given you that first mark. Once you do the algebra, you need to rearrange that so you don't have the M's anymore, and using simultaneous equations, you can work out that U cubed plus V cubed is equal to 4. Unfortunately for part 2, if you didn't get part 1, you wouldn't be able to get part 2. But having obtained part 1, you're just solving 2 simultaneous equations. That's going to give you 2 points. So here was the more difficult part. So what does it tell us? It tells us that m is a positive real number. And what does m represent? M represents the gradient of that particular function. So let's go back and look at when we worked out our gradient. So you can see here that when x equals 2 to the 1/3, it's stationary. That means that when x is bigger than 2 to the 1/3, the gradient's positive, which means that u must be on the right-hand side of that stationary point. U must be a value bigger than 2 to the 1/3. But what about v? Well, g dash to v was negative m, which means that that's where the gradient's negative. And the gradient's negative on the left of, or for values where x is less than 2 to the 1/3. So you need to make that connection to be able to work out which solutions you pick. Now, when we solve that for u, we end up getting 1 minus root 5 on 2, and we also get 1 plus root 5 on 2. But we wanted a value where u was bigger than 2 to the 1/3, which means it couldn't possibly be 1 minus root 5 on 2, because that would be negative, which means we're picking 1 plus root 5 on 2. Once we pick that out, then the v would be the other ordered pair that goes with it, which on a CAS we could have read was 1 minus root 5 on 2 for v. So there, our success percentages again. Some of those were students didn't know what to do, and some of those were students didn't attempt the question. All right, thanks, Robin.
Okay, so Greg, would you say that that was a pretty hard question?
Yeah, it was definitely on success percentage. It was. I had another close look at the exam again today, and questions 1 to 4 really weren't that difficult. So I think, like, the advice I always give my students was that you've got a booklet when you do the exam. You don't have to do the questions in the order they're written. You don't have to do 1, 2, 3, 4, 5 in that order. Always pick the ones you know you're going to do well at first, or think you will. And I think students looking at that, there were things that were harder to read, and students would have made a choice straight away about the fact that that was going to be their last question to attempt. So two
the
reasons
low marks,
for low results.
Yeah,
4 attempts,
yeah,
less
a lot of non-attempts.
Yeah.
Okay, all right. So there's on the screen there, you might recognize this man on the screen. His name is Darren Smith, and he's also known as Maths Guru, and he has a YouTube channel, and he's currently teaching at Melbourne Grammar. He's also working with us and making videos for each of the VCE question analysis in each chapter. So the question that Greg just unpacked, Darren's done a video on it as well, as you can see there. And as you can see, he's using both the ClassPad and the TI Inspire. So here are some more screens there. So he's worked through the video and he's gone through the question as well and explained it. So that's just a bonus thing, a bonus video that we include in our books in all our chapters. So this is for both not just methods, but specialist and general as well. Okay. Next in this presentation is Kim Lowe, who's on our one of our educational consultants. So she's going to give you some more information about the VCmaths series. Thanks, Kim.
Thanks, Greg. Thanks, Robert. That was really informative, and I'm certainly glad I'm not doing Year 12 maths. Before we go to your questions, and I know there's a few of those in the Q&A, I just wanted to take a couple of minutes to introduce you to our new VCmaths series and what options we have for book listing. The series is grounded in research and based on the science of learning and is informed by extensive teacher and student feedback. The series has been designed to save you time, but also to help your students achieve VCE maths mastery. Next slide, thanks, Greg. Thank you. To enable you to choose the most appropriate option for your students, we're offering the VCmaths series as individual components, but also as a value pack. And these options are available for both units 1 and 2 and 3 and 4. So you can see there we've got the student book and Nelson MindTap for $89.95, or we have a value pack which includes the student book, Nelson MindTap and the Mastery Workbook for $99.95. Or if you're a digital only school, you can have the Nelson MindTap only for $49.95, and the Mastery Workbook also comes as a standalone product for $29.95. Next slide, thanks, Greg. If you do offer foundation maths at your school, you'll notice that there's no Mastery Workbook for this particular product because it doesn't lend itself to it. But again, the pricing for the student book and Nelson MindTap is $89.95, or Nelson MindTap only $49.95. Next slide, please, Greg. And if you're thinking of book listing or recommending study guides for your students, then we've got our A+ study notes, and these are available for both math methods and general maths, and are a comprehensive revision and exam guide for students. They include detailed summary notes, approximately 400 revision questions, detailed annotated solutions, and exam and study preparation advice, and these are $34.95 each. And next slide, please, Greg. So if you'd like a more detailed walkthrough of any of the VCmaths series, please reach out to your learning consultant to arrange a meeting. And as Jess alluded to earlier, we understand that things are really difficult and stressful at schools at the moment. So please rest assured that we're happy to work with you to find a time that suits you to meet either in school or online. We do have page proofs available now, so if you're keen to review the actual books, either digital or physical, then please reach out to your learning consultant. And if you're not sure who that is, please reach out to any member of our team, either Anne-Marie, Jill Lim, or myself. And now I will hand back to Greg and Robert, and we'll answer any further questions that you have. Thank you.
Okay, back to us. Okay, Greg, I've been trying to answer all the questions that have come up in the Q&A.
Yep.
As they've come up, and but I've left these 3 to last because they do require a bit of unpacking and a bit of, and it'd be also good that everybody heard our responses live to these questions. The first question is, does the text include any sample application and modelling tasks for students to practice before their SACs? Greg, do you want to answer that first, or?
Well, I know there's a really good question on probability simulation called it's I'm just trying to think what the name of it is. It's on infectious diseases. That's right, and it looks at the process of generating random numbers amongst about a disease that's spreading through a community, and about how if someone ends up getting a disease and they visit someone else and they end up getting the disease again, but you're only infectious for a day, and then you can investigate what happens with how the disease spreads, like it continues to spread till someone ends up visiting someone that has already been infected. And then you can extend the project or extend the investigation and then look at what might happen if the populations were bigger or smaller, or if there are already some people who are immunized in the community. So it's quite a sort of topical thing to look at. And it's something that would lend itself really well to an investigation. So that's like early in Unit 1 for probability. So
yeah.
But probably as a global answer, is there a section which has a heading that's investigations? The answer is probably no.
No. Yeah, the short answer is no. We've got questions. We've got questions that can be extended into a SAC type task, but we don't. Yeah, I mean, as teachers, we find it's really hard to write a SAC or even a practice SAC.
Yeah.
And that's why it's hard to find them available, you know, to
Yes.
buy.
Yeah.
There's also the problem that once it's something that you can buy, you can't use it as a sack, and you can only use it as a practice sack. So in the future, if we did it, we'd have to publish it as a separate thing rather than make it be part of a textbook.
Yeah.
Okay, second question is about in our work solutions, we have a lot of detailed working out, but do we have any places where we show precisely what students need to write? What's the minimum working out required? I would say that in the exam reports, the work solutions that you can find on the exam reports are probably minimum working out without explanation. Whereas in a textbook, we tend to give reasons and show the steps and try to explain the working out. So yeah, we don't have just work solutions that have no explanation. But I think the exam reports tend to have that.
Yes,
what do you think,
yeah.
Greg?
Yeah, I agree. And I think obviously it makes a difference as to whether it's an exam 2 or exam 3, or even an exam 2, whether the question prompts students about, you know, use the result of part A to find something or show something or other. So it depends on the context of the question, like what sort of exam it is and how the question's asked as to how many steps they would need. I know in a lot of them, especially in CAS ones, that minimal steps are required, really. Like you could have simultaneous equations, for example. Let's say they gave you a function and they said the function passes through the points 2, 5, and 3, 6, and your equations could be written as f of 2 equals 5 and f of 3 equals 6. That would be enough for your simultaneous equations, and then an answer at the end would be enough for full marks. But if it said show that x is equal to something and y equals something, that's completely different.
Yeah, oh, that's a good point, Greg. I mean, in our books, we always try to find the most efficient way of solving a problem, answering a question. So if we can do it in CAS in 1 or 2 steps, we'll do that. We won't show the algebra that much. So in that way, we are showing the minimum amount of work required. Somebody's asked about students often have trouble answering show that questions. Does your text have examples of how to do this without writing inane answers? Yeah, just have a look at our work solutions and our solutions to the worked examples.
Yeah.
Okay, Troy asked, are the VCE examples and exam analysis also part of the Year 11 textbook? The answer is yes, but you'll find obviously there'll be fewer VCE questions because the exam tends to focus on Year 12 work. So what do we do instead? We write VCE VCAR style exam questions, and we have exam analysis on VCAR. We create a VCAR style question on the Year 11 topic, and we answer it in the same way. So we try to simulate an exam question if it was based on Year 11 work. So we don't have as many, but as you know, maths is a cumulative subject. So often you will find Year 11 questions on Year 11 work that are applicable to the final exam. Anything to add to that, Greg? So we're talking about
no, I think that's a pretty good answer. Yeah, I mean they're always harder to write, but you know when you're writing an analysis question, you know the structure that they've used in Year 12, and so we stick to that structure. And there's some cases where you can use the actual the body of a question, but you can change the type of mathematics and the level that you end up going into. So you can actually modify some questions to create analysis questions also suit year 11.
Okay, thanks, Greg. There's a question about pseudocode. What is the textbook doing about the introduction of pseudocode under outcome 2 in the study design? Are there any particular places in the text where you have introduced pseudocode? I know pseudocode is an actual topic in the specialist course.
Yeah.
So in the specialist maths books, we have a whole section on pseudocode, but we don't have it in the methods book.
No, it's not in the methods course.
So that's the short answer. Do you think it will be examined? Well, actually, well, I think this is where we're both not experts on this, because we didn't write the chapter on pseudocode. Oh, okay. No. Cambridge have it in their textbook, and it is new in the study design.
Yeah.
Yeah, but if you have a look at the study design, pseudocode is pseudocode is like programming language, but using English words. So yeah, I mean, from what we read in the study design, we still don't know what shape that's going to take. So we don't know whether it will be tested, or actually we don't know how it will be tested, because there's not enough information on it. So yeah, I can't really comment any more about that. And the author who's an expert on pseudocode on our author team, he's not here today. Yeah. All right. Any other questions?
Okay, if that's all the questions we have. Is that all the questions we have for this evening? Has everyone? Awesome. So we'd just like to say thank you for attending, and we've put it in a link in the chat. See it, particularly if you do want to join us for the specialist discussion next week on the 22nd. And again, thank you for joining us and taking the time. We'll send you the recording and the slides first thing next week, and I hope you have a lovely evening. Thank you.